What is chemical engineering? Well, if you ask me, I'd say it's my job. At its most basic level, chemical engineering combines various branches of sciences to turn raw materials into valuable products. Chemical engineers use different tools such as differential calculus, linear algebra, and material balances, and take into account such considerations as economics and safety. But most of you probably don't work in a research lab, so I'll talk about something a little more relatable: coffee. So let's say it's 11 p.m. and I want to grab myself something to drink while I finish up editing this video. But I don't exactly want something caffeinated because I have work tomorrow morning, and if I drink caffeine now, I won't be able to fall asleep. So something I might grab for myself is decaf coffee. But one might ask, how do you actually decaffeinate the coffee? Well, with chemical engineering, we can do just that. So, as always, what's important is to make sure that your measurements are accurate. Now, here I'm being a little looser because this is just my morning coffee. And it turns out that it's actually not that hard to extract caffeine from coffee beans, but the problem is a lot of times you extract everything else, all of those chemicals that give the coffee its flavor. So the challenge then is to figure out a way to extract the caffeine from coffee while leaving everything else in there and still being environmentally friendly and safe. This was exactly the problem with the original method for processing coffee, which was to use water to extract the caffeine. And while this yielded up to a 94 to 96% extraction rate, it did extract a lot of those taste-containing ingredients. So the next method was using a direct solvent such as methylene chloride or ethyl acetate. While this yielded a higher caffeine extraction rate while keeping all of the taste contributing compounds inside, these two chemicals aren't that safe to be around and aren't that environmentally friendly. So now the modern day approach is to use what's called supercritical carbon dioxide. Now this is just a fancy way of saying carbon dioxide that exists at all three states of matter simultaneously: solid, liquid, and gas. So decaffeinated coffee is just one example of what you can make with chemical engineering, but it's much more than just that. Chemical engineering is the gas you put in your car. It's all the beauty products in your bathroom. It's virtually all the food you eat. And while it's more subjects than I care to remember, the fact that I can make anything from cosmetics to beer to life-saving drugs makes all the difference. Hopefully by now, I've convinced you that chemical engineering is a pretty cool field. For me, it's why I get up in the morning.